So I will show you two things. Okay. So one about the initialization part, and then problems you might have with linking. So material in this I think everyone has cloned the repo, or did anyone have problem cloning the repo? So you can go to the code here. I would suggest that that you can follow what I talk by running directly on your computer. So this probably would be the best thing. So there are two folders here inside, which are for the two parts of the talk. And we have executables, and you have codes, and you run it, compile it directly with GCC without using CMake. So I will show you. So first, global and static variables are initialized when the program starts before every other variable, and deleted when the program ends in reverse order with respect to the initialization. And they're not stored in the heap or in the stack. They're stored directly in the X usually. And they tell us we should not use it. It's true, but it happens that you might work on a program on a library that uses static variables, and they can be useful. So you might want to use them. For instance, in implementing design patterns like factory or singleton, and interacting with other programming languages. If you're working with Fortran code, it might be useful to instantiate global variables. Or also, for instance, if you work with CUDA with GPUs, if you want to use CUDA constant memory, one of the ways is to instantiate a global variable, and this will be in constant memory. And there's not many other ways to do that. So sometimes it's just useful to do it. So first thing, so these are the two static variables. I define two structs with a static int inside, and then I initialize it here at global scope, and then I run the main. So here you see that in initialization, there's one static variable depending on the other. So this static variable is depending on this other one. So what would you expect as a result? So if it follows the program order, you would expect the initialization to initialize this first, and this gets initialized because this s_c is known. So this is what it happens. So okay, this gets initialized to 50, this is 5. So everything seems to work nice. So what if we swap the two? Then, so you would expect that this thing is not initialized yet, because this initialization happens after in program order. So what happens is it works anyway, independent of program order. So you start to smell that there's something weird with static variables initialization. So why doesn't it respect the program order? So we try to extend the examples with 3 structs, where the first one is initialized with 5, and the second one depends on the first one, and the third one depends on the second one, or well, the other way around. So what happens here? You get everything seems to work nicely, like you get things initialized properly. What if you exchange the program order in this case? Then you get that the first one is initialized to 0. So the f. So this is not okay, and there's a dependency on the initialization order. So the thing is, initialization of if you use initialization of static variables which depends on each other, that might be painful. Now I showed you examples where all the variables are initialized in the same translation unit, which means they're all in the same CPP file. But usually in the normal libraries, you get different static variables in different translation units, and you have no control on the order in which they get initialized. So if you get static initialization depending on other static variables, you don't have control on the initialization. So in some case, with some compiler, you might get the right result. Some other compiler, you might get the wrong result. So it's a bad practice to use them. So even if they are in the same translation unit, you can get surprising behaviors. So how do you solve these problems? One is to avoid using static variables, but sometimes we don't want to use them. And other two strategies that I will talk about are using the constant initialization instead of the normal zero initialization used for static variables, or use the initialize and first use idiom. And for those who don't know what a translation unit is basically the code required to compile a single object file. So it's a CPP file, all the headers included by this CPP file, and all the code needed to compile this object file. This is called translation unit. So what if this is the example which is not working? So you can find it here in the I think I have the 1 second. I have a share here. So an example CPP in code. Static variables, initialization. So here, usually I write the name of the example in the header. So you can try to compile this. G++. Oops, sorry. So first. So you see that you get this result, and so if these three are constants, so you can use the constant initialization instead of the static initialization, meaning that you define them as expression, and in this case you initialize them here, and you can define it for external linkage in the global scope. And in this case, you get the initialization work properly. So you can try it out and play with it in the example. But what if you don't want them to be constant? So you want to be able to change the variables. So in this case, you can use the initialize and first use idiom. That you define your static variables inside functions, and then you test the variables with by calling the function. You see that you calling a function initializes a static variable and returns it. So now you say you spend a lot of time talking about Rai, and then you define a local variable and return a local variable. So this works because these are static, so their allocation is not on the stack, which usually is for normal local variable. These are not local variables, and since they are static, they will be initialized only once. And the first time that you call the function, they will get in. The second time, this part will be skipped, and it will be just return this value. So out in this actually this is the wrong file name. It's called first touch. First touch in it. So you can try out, and you can add printfs to see what's happening, and so the initialize and first use then. So uses static variables which are in function body. They're constructed, they're initialized when the functions gets called, and then they are destructed in reverse order with respect to the initialization. They're constructed only once, even if the functions are called multiple times. And this thread saves in C++11 is guaranteed that access to static variable are thread safe. What this is done, adding mutually exclusive execution in for accessing the static. So, is this thing magic? I think it's not magic. So you can check inside the compiler explorer. This is a short link. I have it already somewhere here. Now, here it is. So here I have exactly the same example as in the that you have in the file. So I'm calling f multiple times. So what happens is that it instantiates these guard variables. These guard variables, they check that if it's the first time that you enter in the function f, then you initialize the static variable. Otherwise, you skip the initialization and you just return. So this thing gets executed only the first time that you call f. And the second time, it's only return the mf, which is already initialized. But this has a cost. It adds an if, basically, inside here. So in your main, you might not want to call this f multiple times because it just creates all this assembly, like all these branches, which are executed at runtime. You see? So instead, what you want to do is the following: to instantiate it once, to cache it. You cache the static inside the local variable on the stack, and then you call this multiple times. So in this case, you get a very small assembly code, and so this is in the optimized version. So it doesn't get optimized automatically. You have to do it by hand. So there's a cost. It's not magic. This initializing first you, and also there's two costs. One of this one, and the other one is the fact that it's thread safe, the static variable. Since it's thread safe, it adds a mutex, which has also some costs. So this was the first part. The part is about the linking. So you can see in the factory design pattern, for instance. Usually people use static variables. So let's say that I have a static bool reg inside an HPP file, and so in a templated class which is called registered product, and then I instantiate two of the templated reg. So this is the syntax of the lambda, which we didn't see yet. But what this is done is that it's defining a function which returns true and prints initializing double. And then what these parentheses do is that they call this function. So this initializes reg by calling a function which is defined here in line. This was just to save space. And the same thing is done, and this is a specialization for double and a specialization for float. So if this t is double or float, then I have the definition for this reg boolean. Then in my main, I include this init static.hpp. So this will be in another translation unit with respect to this. And what will be the output of this then? Will this initializing double and initializing float be called? So who thinks that this will be printed out, initializing double and in float? So we can try. So it's called test static. Okay. Init static. No. Wait. Yeah, I need both. I need also init static, yeah. So, so it calls initializing double, initializing float. So it actually initializes these two because they're called here. So I'm calling reg for float, and I'm calling reg for double. Oops. But so now, what if I comment this out? So now they're not used anymore in the main. So so I comment this out. What will happen? They get called anyway. So they're even if I do not doing anything in the main, these two things get initialized by calling this initializing double and initializing float. So all the static variables get initialized when the program starts, even if they are not used anywhere. So that's what we conclude by this example. Now, okay, that would be good because we can initialize. So in a factory pattern, we can automatically initialize, register our product in the factory without the user knowing anything. The user has an empty main, and the products get registered. So awesome. So now, suppose that you're developing a library, though, and so you have two transaction units. So the user writes a main file, and you register the product in a separate translation unit. So what you do is that you first compile with -c, so that you create an object file. Then you create a shared library with your object file. You can copy paste these things in your shell and try it out. So you generate this library libs.so. Then you can compile your test static by linking this lib.so, which is a shared library. And then you can run it, and you will see that it prints initialize floats, initialize double. So it works. Even if you are compiling it into a library and then you're linking the library with your executable, this is very good. So, but what happens then if you want to compile a static library? If you want to do the same thing, but you want your executable to be compiled statically. So you do the same step as before. So you compile the init static into an object file. Then you create a static libraries, and this is the command you use to create a libs.h, which is libs.a, which is a static library. Then you compile your tests and link the static library, and then you execute. And what happens is that these variables, they don't get initialized, because the linker, since this executable is statically linked, the linker knows that you will not use those variables anymore, so it removes it from the executable to save space and to save space, basically. And so these static symbols have been removed, And this pattern is something that you can encounter. So it happened to me to encounter. I know at least one from the CFD communities. Maybe there's someone who used OpenFOAM. OpenFOAM uses this pattern. So if you try to link it statically, you will have an error because of that. And it's very, very difficult to find this error. It might happen that you might want to use it also, but so it's not a portable thing, because if you link it statically, it will not work. So the take-home message is that the static initialization is difficult to debug, and if the static variables have complicated constructor, if you get an error there, then it's your own. And so try to use constant initialization when possible, or initialize and first use idiom, though it has this performance drawback that I showed. And do not rely on static initialization side effect, because it's not portable. Or at least if you find that something is not working, like if you try to link a library statically, like OpenFOAM, and you see it's not working, it might be because of that. So thanks. Finished. Thank you.